Welcome to Session 37 of Grade 11 Advanced Algebra and Precalculus. Today we study logarithmic graphs and transformations. The focus is to graph logarithmic functions using inverse relationships, vertical asymptotes, and transformations. By the end, you should be able to do these three things. 1. Find the domain from the logarithm argument. 2. Identify the vertical asymptote. 3. Transform key parent log points. A logarithmic graph is the inverse shape of an exponential graph. It has a vertical asymptote because a logarithm can only accept positive arguments. For g of x equals a log base b of x minus h plus k, the vertical asymptote is x equals h. Analyze f of x equals 2 log base 3 of x minus 4 plus 1. The argument x minus 4 must be positive, so the domain is x greater than 4, and the vertical asymptote is x equals 4. The parent point 1, 0 shifts to 5, 1. The parent point 3, 1 shifts to 7, 3. For h of x equals the log base 2 of negative x. The argument is positive when negative x is greater than 0, so x is less than 0. This reflects the parent log graph over the y-axis, with vertical asymptote x equals 0. Your turn. What is the domain of log x minus 6? Pause the video and solve it. Here is the solution. Work line by line, then check the final answer against the original question. After the video, complete these three tasks. Copy the model from the lesson. Solve each one fresh, and write one error log sentence about the mistake you are most likely to make. Let's recap. Logarithms accept only positive arguments. The boundary of the domain is the vertical asymptote. Log graphs are inverse shapes of exponential graphs. Transform key points to anchor the graph. Before moving on, write one sentence. The step I must protect is. Then read more in the explanation below the video, and visit www.bridgetoexam.com for more learning support.